All right, so what we're gonna do is we're gonna try and solve it graphically first. And the first thing we're gonna do is we're gonna try and draw some parallel axis according to where this force is going. So this force is going left. We're gonna first draw the scale. So we know that 1 centimeter is gonna be equal to 10 pounds of force. That's gonna be our scale. And we know that this force is going to be acting along the horizontal. So we're going to try and draw a line as horizontal as we can along this way. And we're going to try and make it somewhere close to 5 centimeters. So we're going to have this right here. That's 4, just one more. That becomes 5 right there. All right, so what will end up happening is that theta that is given to us right here is 53 degrees. Doesn't really seem to fit the scale of what this picture is trying to give to us, because at the end of the day, we're going to end up drawing another parallel axis right around this right here. We're going to call this a resultant, and we're going to call this our other axis, and it's going to have an arrow here, and it's going to end up coming back to here. And what will end up happening is that this theta is going to be too small, and we're not going to get an accurate result because it's not going to fit the right scale according to what's given to us. So we're going to try and draw a similar triangle down here that is close to what this triangle would be. So what would happen is we have this horizontal right here, and since we have two horizontals, this will end up becoming 20 degrees. And since this is 53, then we're going to do 180 minus 20 minus 53, because the triangle has all sides, all angles must add up to 180. So what we'll have is we're going to end up with 107. So 107 degrees, this must measure 107. This will be opposite to this. This will be 53, and this will be 107. So we're going to try and draw a similar, something that would kind of replicate those angles. So what we're going to draw then here is we're going to try and draw the same scale. So draw a horizontal, and this will be close to 4. We add up one more, that'll be 5. And we're going to try and draw something that is close to 20 degrees right here. So that seems like it's close enough. And this will be one of our components. Oh, don't move. And we're going to draw the triangular line. Then what we're going to do is, so this component will be parallel to this. I'm going to draw a little bit longer. We know that this is 107, so we're going to draw an arrow right here. This is 107, so we're going to try and make this angle right here 107. So we have this. This is somewhere close to 107. So we'll end up getting close to right here. And tell the 2 points. All right, so this right here will be one of our components, and this right here for your other component. So this will be our point A, this would be B, and this would be C. So our force right here is 50 pounds. This angle is 20. This angle is 53. And this is 107. With our scale, we're going to try and measure these components and see what we get. So this one is just about, we got 3 here. We got another 3 right here. This is just about 60 pounds because we got 6 centimeters. So 6 centimeters is going to be equal to 60 pounds of force. And this one right here is just a little bit more than 20, a little bit more than 2 centimeters. So it's just about, say, I'm going to call it 2.1. It's going to be equal to 21 pounds. So those are going to be our 2 components. So our force in the AB direction, it's going to be equal to, technically would be in the B to A direction, since our component is going in the opposite direction. Let's call that BA. It's going to be equal to 21 pounds. And our component for the A to C direction is going to be equal to 60 pounds. And now we're going to try and solve this analytically. And so what we have is we have these angles, right? We're given this 20 degrees, we're given the 53 degrees. With the proper geometry, we can determine that this is 20 because we draw a parallel axis right here, and opposite angles with a parallel become the same. This one becomes the same as this one, and they all add up to 180. So they become this. We have 50. What we can do, we can use the law of sines to determine the other side. So what we can do is we can take the sine of 53 over 50. It's going to be equal to, we're going to name this one B, and this one is going to be the other B side, and then A side will be according to this. So the sine of 20 over A, and it's going to be equal to this to this. So the sine of 107 over C. So we're going to use this to solve for A. What we can do is we can take the sine of 53 times A equals 50 times the sine of 20. We're going to divide the sine of 53 both sides. And we take our calculator and take 50 sine 20 and divide that by the sine 53. And that's going to be equal to 21.4. So that seems to be very close to what we got here, pounds. And our second one would be the sine, 50 times the sine of 107 divided by the sine of 53 would be equal to 59.87 pounds. So our force analytically in the VA direction is equal to 21.4 pounds, and our force in the HE direction is equal to 59.87 pounds. So it's pretty similar to what we got here, being this being 60, this being 21, and this is going to be our final answer for this problem.